So very good evening to all my dear students. So today we are going to see functions. Okay. Um, shall we start the class now? Am I audible, ma? Students, you please answer me. Akash, are you there?
Yes, sir. Yes, sir. Audible, sir.
Yeah, my screen is visible to you all now.
Yes, sir. Yes, sir. The slide is
Right.
visible.
Okay, ma. Right. So today we are going to see functions and logarithms. First, we will see about functions. I will give the basic definition of functions, and then we will see some problems, then followed by logarithms. I will give both functions and logarithms basic definitions and basic problems. Okay, and also I will give you how to identify the functions. Okay, how to identify the functions, and then we will solve based on the definition. We will solve some problems. Okay, then we move on to logarithms. First, functions. A relation f which associates to each element of set A. Here note down that set A exactly one element of set B. So set A and set B associate with one element. So is called a function from A to B and is denoted as f from A to B, or we can read it as f maps A to B. If suppose B equal to A, then f is said to be a function from A to A or in A. If A comma B belongs to f. So suppose a function is contains A and B, then B is called image of A under f. This can be written as B equal to f of A, and A is called pre-image of B. Now, f maps A to B, then A is called domain of f and B is called codomain. So here A is called domain and B is called codomain of f, and the set R is equal to f of A such that A belongs to A is called range of A. So a function which contains both domain, codomain and as well as range. The range of f is also called image of f. Okay, the range of f is called also image of f and is denoted by image of f, im of f or f of A. So now we will see two diagrams. Here there are two diagrams, function and not a function. First we will deal with the function. So what is meant by function? Okay. Yeah. So what it's told, one second, I'll take my time. Set A and set B. I have told two sets. Okay. So we are connecting f from A to B. So set A is called domain. Set A is called domain. Set B is called codomain. Set B is called codomain. Okay. So each and every element should map with 1 to 1. That is, here I am having 1, 2, 3. Here in codomain I am having A, B, C. 1 is related to A, 2 is related to B, C, 3 is related to C, or otherwise. So this is domain. Okay, this is domain, and this one is codomain. Okay, so domain and codomain part. Here 1, 2, 3. In codomain I am having A and B. So here I am connecting 1 with A, 2 with B. In domain 3 is connected to B. So this is also called as a function, whereas not a function. So I have shown in the diagram, not a function. What is that? See here, 10, 3, 5, 7, 2 in the domain. Okay, so always we should see the left hand side we will have domain, the right hand side is codomain, or you can write codomain or domain. So it is your choice, you have to decide that domain and codomain. Okay, right. So 10 is related to 2, 3 is related to 3, then 5 is mapped to 4, then 7 is mapped to 5, 2 is mapped to 5. See the 5 number, the number 5 is mapped to 2 terms, 4 and 7. So it is not a function. A domain should always mapped with only one term, okay, only one term in codomain. See here, the 4 is mapped, see here, the 4 is mapped with 8 and 5 also mapped with 8, okay, right. So is there any doubt in function? How to define a function? A function is nothing but, okay, a function is nothing but domain to codomain. We have a relation, single relation. We have to follow a single relation. Okay. Next part. Domain, codomain, range, and image. So let F match A to B. Then set A is called domain of the function. Set B is called codomain. So earlier what we have seen, here I have given as a definition. The set of all images, listen carefully, the set of all images of all elements of A under the function F is called the range of F and is denoted by F of A. The range of F of A is defined F of X such that X belongs to A. So F of A is a equally subset, that is subset of B. F of A is a subset of B. If X belongs to A and Y belongs to B, and Y equal to F of X, then Y is called the image of X under F. Okay, right. Next part. One-to-one function, or otherwise it may be called as injection. See the diagram. Okay, before we are going to see the definition, see the diagram. How can you see that? That is, what was that? The relation X is mapped to F of X and A is mapped to F of A and B is mapped to F of B. Here A is called domain and B is called codomain. Now we will see the definition. A function F from A to B is called one-to-one function if distinct elements of A have a distinct element in B. So one-to-one functions are also called injective functions or injections. Okay. If F from, that is F maps A to B is one-to-one, if x1 not equal to x2, which implies that function f of x1 is also not equal to f of x2. Equivalently, f of x1 is equal to f of x2 implies x1 equal to x2. Next part, onto function. Onto function means surjection. So we have to know the difference between injection and surjection. Okay, a function f from A to B is called onto function if every element of B is an image so I'm not able to pick up the pen. Okay, so if every element of B is an image of at least one element of A, okay, see here the domain A is mapped to codomain A, B, C, D. For function and onto function, then one-to-one function, all the functions from domain to codomain, each and every element is mapped. So each and every element is mapped. F of A, that is F from A to B is onto if each Y belongs to B, there exists X belongs to A. See the third line, listen carefully. If for each Y belongs to B, there exists X belongs to A, such that F of X is equal to Y. Onto functions is also called as surjective functions or surjections. So I will, while explaining the problem, while seeing the problem, I will tell you in detailed manner. Okay. Now, next, identity function. Identity function is nothing but easily you can identify from the diagram itself. One is mapped to one, same common domain and as well as codomain. Each and every element will be identical with the same path. The function f from A to A is defined by f of x is equal to x, is called the identity function and denoted by IA. Next, inverse function. If f maps to A to B, or you can read it as f from A to B is bijective function, then the function f inverse from B to A, that means, once again, f from A to B, this is the normal function. Then whereas f inverse means which is B to A, inverse function. For example, f of x is equal to y means then we want to write the inverse function. So f inverse of y is equal to x. So this is called inverse function. F inverse of y is equal to x. Okay, right. See, domain of f, that is range of f inverse here, then range of f, domain of f, range of f. Here x and y. See here, range of f inverse, domain of f inverse. So x to y, here y to x. Okay. If f from A to B is bijective function, then f inverse is also B to A. That is also called as bijective. So if f of A is equal to B, then listen here, the second node, A equal to f inverse of B. Okay, right. Composite function. See, if f from A to B and g from B to C are two functions, okay, are two functions, then g of f of A for every A belongs to A is called a composite function of f and g. Is called composite function of f and g. So it can read as G circle f. So it is denoted by GOF. That is the circle. So sometimes we may call it as GOF. Okay. So actually you have to read as G circle f. So A to B is a function and B to C is a function. So here the function is called as f. Here the function is called as G. So the composite function of A and C is called as GOF. That is G circle f. Okay, right. Next one. Even odd function. So I think you have earlier you have seen that even odd function in the during your first and second semester. So many places you have used that even odd functions. A function f of x is said to be, okay, f of x is said to be odd. That means, so f of x is equal to minus f of x. If you are getting f of x is equal to minus x, while replacing, okay, while replacing f of minus x is equal to, suppose you are getting that f of minus x is equal to minus f of x means it is an odd function. Okay, then even function. So f of x is even means, f of x is even means, f of, suppose you are putting f of minus x means, again you are getting the same function, it is f of x, again you are getting the same function means it is called even function. Okay, even function. So we will see an example. F of x, f of x is equal to x square first. So now I'm going to replace minus x here. So minus x the whole square is equal to x square. Again I'm getting f of x here mark. So it is an even function. Then f of minus x is equal to, suppose I'm putting x cube. So minus of x whole cube equal to minus of x cube, which is minus of f of x, is an odd function. Is an odd function. Okay. So even and odd function. A function f of x is said to be even function if for any number x in its domain minus x is also there in its domain and f of minus x is equal to f of x. So the graph has symmetrical across the y-axis. So symmetrical across the y-axis. I will show the graph on the next slide. So example, x square plus 5 is an even function. Then cos x is also an even function. Okay. a function f is said to be odd if for any number x in its domain minus x is also in its domain and f of minus x is equal to minus f. The concept is, if suppose you are applying negative term for that function, if you are getting the same function means it is even. If you are getting the negative function means negative of that function means it is an odd function. Okay. So the graph remains same after rotation of 180 degrees. Okay, after the rotation of 180 degrees. Right one. See here, even function. Function unchanged when reflected about the y-axis. See, here the function is reflected. Here also we are having the same curve. Here also we are having the same curve. It is reflected from in the y-axis. Okay, in the y-axis the same as it is. Function is unchanged when rotated about 180 degree from the origin. Okay, about the origin. See here, the curve is coming from here. So here this rotation is happens. In the origin, it was moves to 180 degree. Okay, then the curve remains unchanged. Okay, there remains unchanged here. Okay, the same shape in the above the x-axis and below the x-axis also we are having the same thing. Okay, it is called odd function. Okay. Next part. Now we are moving to problems. See, the set A and B are given as A equal to A, B, C, D. A is equal to A, B, C, D. Okay. Then B is equal to A, D, I. Find A union B, then A intersection B. Okay. Then A minus B, B minus A, then A cross B and B cross A. Okay. First, I will do one thing. We will write the function. Okay. So we will solve lively. Okay. So what is our A ma? A is equal to what I have told A comma. One second. A B C D. Yeah. Yeah. So A B C D. Then B is equal to pa? A D I think so. Am I right? Yeah. A, B, I. First, we are going to find A union B. So always you should remember while you are writing for the competitive examination or UPSC examination, whatever the aptitude examination, whatever the examinations you are writing, that you should always remember A union B. So union is combining the two terms, okay, or otherwise we can say, here I have given here. See. A union B is set of elements which are in both set A and A union B. Okay. A union B set of elements are both in set A and set B. Common elements. Okay. Common elements. Okay. So here A union B means we have to combine everything. Okay. A union B is we have to combine everything. Okay. So A intersection B means what? A intersection B. So anybody can tell the answer. A intersection B means what?
BCI.
B? No, A union B.
CI.
C. D, I think so. A and I only ma. Intersection means you have to combine both A and B. So what are all the common terms in A and B? A and
AD.
A, D, 1 second. Yeah, A and D. A, comma, D. Then A union B means A, B, C, D, then I. Next come. So, A minus B. A minus B. Anybody can tell the answer? A minus B means. I'll just tell you the definition. A minus B.
B comma C.
B comma C. The set
B
of all
comma C.
elements. Yeah, the set of all elements that are present in set A, but not in the set B. See here, I have given the relation as or and not. You have to remember these three things while you are applying for union or intersection, or suppose you are subtracting two sets. Here we are dealing with the sets mark. Two sets. So we are subtracting with the two sets means while you are using my negative sign, okay, while you are using the negative sign, the set of all elements present in set A but not in set B mark. So here a minus b, b comma c, and also b minus a. See here only we are having the answer as I. B minus a is the set of all elements that are in set B but not in set A. So always you should remember this not part while you are subtracting two sets. Okay. So these A cross B and B cross A are you can easily write. Okay, that is you can easily answer for A cross B and B cross A. Set of all ordered pairs with the first element from set A and second element from set B. Okay, first element from set A and second element from set B. So I think we are having I don't know. It is not present. The pen is not giving us impression of it. 1 second. So first element in A and second element in B. Okay, the first elements here A, A, A. We are combining with the A, D, I, then B, A, D, I, then C, then D. Okay, here also B cross A, the first element from set B, the second element from set A. Okay, next part. If A equal to ADFH, then R1 A comma F, A comma H, F comma H, and R2 A comma D, D comma F, F comma H, and A comma H. Then find R2 inverse. R2 inverse. Okay, we know that R2 equal to A comma D, D comma F, F comma H, A comma H. So whenever they are asking inverse means you write in a reverse order. Okay, reverse the order. See here R2 inverse is nothing but D comma A, then F comma D, H comma F, okay, H comma F and H comma A. So this union is as usual, what we have seen in the previous problem, the same as it is. R1 union R2 is equal to A comma F, A comma H, F comma H, A comma D, D comma F. So R1 intersection R2, A comma H, F comma H. So third problem, which of the following relation is a function on A 1 comma 3 comma 5 comma 7? So you just don't ignore the solution. Okay, you tell me the answer, which one is the correct option, and tell me which one is not correct. So which are all not correct here? See, F4 is a function of A. F4 is the function of A. Here 1, 3, 3, 5, 5, 7, 7, 1. It is having a cyclic relation. Okay. So it is having a cyclic relation. 1 is mapped to 3, 3 is mapped to 5, 5 is mapped to 7, 7 is mapped to 1. Then F1 is not a function. Why it is not a function? Okay, why is not a function on A? As 1 has more than one image. See here, 1 has more than one image. In first option, this is the domain, this is our codomain. 1 is mapped with 3 and 5 and 7. So it is not a function. Okay, it is not a function. Okay. Then same as F2, 1 mapped to 3, 3 mapped to 5, 5 mapped to 7. Okay, F2, F3. 3, 5, 7 have no images in F2 and F3 are not functions on A. Okay, right. So next part. So which one of the following is an even function? So anybody can tell the answer, which one of the following is an even function? Even function means what I have told, we have to put, instead of x, we have to put minus x. So we will treat it as a function, that is f of x is equal to modulus of x square minus 5x. Okay, then we have to put f of minus x. So use options for solving. If a function is even, it should satisfy the equation f of x is equal to f of minus x. We now check the four options. Okay, so f of x is equal to modulus of x square minus 5x. By putting minus x, okay, I am getting negative of f of x. So it is an odd function. For option B, x power 4 plus x power 5. Here itself we can decide. X power 4 means we will get even. X power 5 means definitely we are going to get odd only. So it is also an odd function. Next option. So checking for option C, f of x equal to e power minus 2x plus e power minus of 2x. Okay, here positive 2x and here negative 2x in the exponential order. Now we are putting that f of minus x here. So e power minus 2x, here minus of minus is going to be plus. So e power minus 2x plus e power 2x, it is an even function. So the answer C is the correct one. So for D also, suppose we are putting negative here in the denominator. So numerator there is no problem because we are having modulus. The purpose of modulus always it is going, suppose we are giving negative term means it is going to give as a positive term. So modulus f of minus x, that is minus x modulus of square means again is going to be modulus of x square, then negative x is coming as negative, okay, minus of f of x. It is an odd function. Okay, now f of x is equal to, next problem, f of x is equal to e square x plus 3x square. So g of x is equal to f of x plus f of minus x divided by 2, and h of x is equal to f of x minus f of x divided by 2. Show that g of x is even, h of x is odd. How can we prove these two? Any idea?
Yes, sir.
Any idea? Yes, Pa. Just tell me the idea, I will solve it. Yes, pardon, I can't understand.
If g of x equal to g of minus x, then it is set to a even function, no, sir.
Yes,
Then in a x place, we have to substitute minus x once and x once, sir.
So here simply in these two functions, I'm going to replace instead of x minus x. So finally we will check what we are getting the answer. Okay, that is the solution. See here, g of x is equal to f of x plus f of minus x divided by 2. While g of minus x is equal to f of minus x plus f of x divided by 2. As g of x is equal to g of minus x, therefore g of x is even, it is proved. Okay, then if h of minus x is equal to minus h of x, then h of x is said to be an odd function. Here also the same procedure we are following, but see the answer. While I'm putting minus x here, f of minus x minus of f of x. So the function is the negative of that function, that is minus of h of x. We are getting the solution as minus of h of x. Therefore, it is called as odd function. Okay, right. Check whether the given function is odd or even. H of x, 1 second, h of x is equal to, yeah, h of x is equal to 2x minus x square. Now tell me the answer. So h of x is equal to 2x minus x. H of minus x is equal to, here itself you
Neither
can,
even nor odd, sir.
yeah, you neither even or not. Here itself you have to decide because you are writing the aptitude examination means you won't get time to solve. Okay, so then and there you have to decide your answers, ma. Okay, so you have to take within the 1 minute. You have to calculate everything on your mind. Okay, so 2x means negative of 2x. Then x square is compulsory is going to be positive. So h of minus x is going to give an answer of minus of h of x. So minus of not equal to minus of h of x, and it is not equal to h of x also. Therefore, we can conclude as neither odd nor even. Okay, neither odd nor even. Okay, next part. So compute the inverse of the function f of x is equal to 2x plus 1 divided by x minus 5. So let y equal to f of x. Okay, y equal to f of x. Here I'm just cross multiplying it. 2x plus 1 is equal to yx minus 5y. I'm just rearranging this one. Okay, I'm taking this x terms to left hand side, y term to right hand side. Okay, so x into y minus 2 is equal to 1 plus 5y. Now I'm getting x as 1 plus 5y divided by y minus 2. So f inverse of y is equal to 1 plus 5y divided by y minus 2. But the problem is given as f of x is equal to 2x plus 1 divided by x minus 5. They asked us to find for this f of x. Therefore, f inverse of x is equal to 1 plus 5x divided by x minus 2 by putting y equal to x here. Okay, next part. Same procedure. So, which one? Yeah, if x varies from minus 1 to plus 1, find the inverse of this function. Okay, so these are all the 4 options. Can anyone guess which one is the correct answer? Then I will show the answers for you. Just guess it, whether it's right or wrong, that is not a problem. You just guess an answer, then we will see the detailed answer. Option A, B, C, D. Any answers? Anybody
sir.
can tell the answer. Which one, Pa? B, yeah. Okay, then any other answer? Okay, so we don't want to waste our time. So one boy is told that B is the correct answer, so we will see the answer. Now f of x is equal to 3 power x minus of 3 power minus x divided by 3 power x plus 3 power minus x. Let f inverse of x is equal to y, therefore x equal to f of y. So x equal to 3 power minus y, then 3 power minus y here. Yeah, 3 power minus y. Here I'm just multiplying with 3 power y, both numerator and denominator. I'm getting 3 power 2y minus 1, 3 power 2y plus 1. So I'm just cross multiplying this denominator. So x into 3 power 2y plus x, then 3 power 2y minus 1. As usual, last one, what we have done in the last problem, I'm just rearranging this one. Now 3 power 2y is equal to x plus 1 divided by 1 minus x. Taking logarithm on both sides. Here I'm considering this base as 3. So no one is going to tell you have to consider as base 3. Okay, you have to decide, because according to the answer you have to decide that logarithmic base is 3. Okay, so I'm taking log on both sides. So log of base 3, 3 power 2y. Here I'm using log of m base n, that is log m n. We can call it as n log m. Okay, based on this formula I'm writing 2y is equal to log base 3, 1 plus x divided by 1 minus x. Sorry, 1 plus x divided by 1 minus x. Therefore, the answer y equal to 1 by 2 into log 3, 1 plus x divided by 1 minus x. And the boy has told the answer as B option. So the answer is A. Okay, the answer is A. Okay, the answer is A only. Okay, now so the composite function, we are moving to composite function. If f of x is equal to 2x plus 3, then g of x is equal to log x. X ranges from 0 to pi by 2. Then find GO x, GO of FOG or GOF. Both we have to find. Okay, we are going to find FOG of x and GOF of x. So FOG of x, that means, which is called f of g of x. Okay, first we are finding g of x. So g of x nothing but log of cos x, which is 2 into log of cos x plus 3. So g of f of x is also giving the same answer, but listen carefully, both are not equal. So both are not equal. Don't conclude that both are equal. There we are having 2 into log of cos x plus 3. Here log of cos of 2x plus 3. Right. Let f of x is equal to x cube minus 2x square plus x, and g of x is equal to x square minus 1. What is the answer for f of g of 2? See, these kind of problems they will ask regularly, Pa. During that time, you have to deal with that is g of 2. First, you deal with g of 2. Find the answer for g of 2. Calculate g of 2 and plug into f of x. First, you find the answer for g of 2. G of 2 answer is 3. Then you replace in second one. That is, what is the second function? F of x. Okay, you have to follow in the reverse order. Now, first you have to solve, while solving the composite function, you have to solve the bracket. Okay, first, what is the first bracket? We are having g of 2. You solve this one, then you substitute the answer in the second one. Okay, then f of 3 is equal to 3 cube minus 2 into 3 square plus 3. So the answer is 12. The first one answer is 3, the second one answer is 12. Next part. So is the function f of x is equal to root of x plus 1 is 1 to 1. Now they asked us to check 1 to 1. So 1 to 1 means what I have told you. So 1 to 1 means each and everything should have a what I have to do. Yeah. So function 1 to 1 means that should have pre-image. Each and every element in domain should have a pre-image in co-domain. Okay, should have pre-image in co-domain. Okay, So each and every element, A is f of A, B means f of B. So we should to have three image in the co-domain. So now here the function is f of x is equal to root of x plus 1, root of x plus 1. So I'm considering as two functions, f of a is equal to f of b. Now root of a plus 1 is equal to root of b plus 1. Therefore root a is equal to root b. So root of the function f of x is equal to root x plus 1 is an one-to-one function. So how we are concluding this one? Here root a is an image in domain which have a pre-image in codomain as root b. Okay, pre-image in the codomain as root b. Next part. Give G maps from R to R. Given G of x is equal to x power n minus x is 1 to 1 or not. We have to check it is 1 to 1 or not. G of x is equal to x power n minus x. So I'm putting G1 here. So G of 1 is nothing but 1 power n minus 1. 1 minus 1 is equal to 0. Therefore, G of 0 is equal to 0 power n minus 0. So obviously you can know G of 1 and G of 0 is equal to 0. So it is not an 1 to 1. Why it is not an 1 to 1 pair? Always it should have an image to pre-image. Okay, both domain and codomain it should have images. Okay, so A in domain, suppose we are having A as image means the pre-image of codomain should be f of A. Okay, right. Next part. So find the domain of each function. F of x is equal to 2x minus 1. F of x is equal to x squared. Here y is equal to 2x minus 1. Domain is x and range is y. I'm just taking some points in domain minus 2, negative and positive, both negative and positive. Minus 2, minus 1, 0, 1, 2. So here the range is, I'm substituting these x values in that equation y equal to 2x minus 1. I'm getting minus 5, minus 3, minus 1, 1, 3. See the domain F is the set of all real numbers R. The set of all real numbers R. This ranges from minus infinity to plus infinity. See here, both minus infinity to plus infinity is involving, both negative and positive are involving. Okay, same as second problem also. F of x square is also ranges from minus infinity to plus infinity. Okay, next part. So which of the following two functions are identical? How can you find the identical function? I have told you that identical function means each and every element should be same. Each and every element should be same. Here, A, B, C, there are given three functions, f of x, g of x, h of x. Is there any relation between these three functions? So what is the answer? For two functions to be identical, their domain should be equal. For two functions should be identical, their domain should be equals. Domain, see here mentioning that codomain also, domain and codomain, both the domains should be equal. Okay, here none of them are equal to each other, therefore the answer is none of these. Okay, none of these. Okay, right. Next one. So if f of x square minus 1 is equal to x power 4 minus 7x square plus k1 and f of x cube minus 2 is equal to x cube minus 9x plus k2, find the value of k2 minus k1. Here they have given four options, 6, 7, 8, 9, none of the above. So how to approach these two equations? Okay, there they have given x square minus 1 in first function, second function x cube minus 2. I'm approaching these two functions. In first function, I'm replacing x square as 1. So f of 1 minus 1, that is, I'm going to find f of 0. So f of 0 for the first equation is minus 6 plus k1. Second function also, x cube, I'm just equating to 2. Why I'm doing this 1 and 2? Why I'm substituting 1 and 2? So I want to find equal values for k1, k2 minus k1. Okay, that is, I'm just replacing the function is to 0. So f of 0 is minus 6 plus k1 in equation number 1 In equation number 2, f of 0 is equal to minus 14 plus k2. To make it as 0, I am substituting x square as 1, then x cube as 2. Now, by equating these two equations, minus 6 plus k1 is equal to minus 14 plus k2. Or otherwise, we can tell is that k2 minus k1 is equal to 8. The C answer is correct. The correct answer of choice C is 8. Next part. So, if f of 2 comma 7 is equal to 57 and f of 1 comma 6 is equal to 37, what is the value of f of 3 comma 10? 107, 127, 147, none of the above. Listen carefully. See the final digit of 1, 2, 3, 777. So there you have to think that your answer is going to be end with 7. So according to that, you have to these are all you have to think by yourself. So we have to, some relations are there with the function. Okay, first f of a comma b, a cube plus b square. I'm just defining 2 cube plus 7 square, that is 8 plus 49 is equal to 57. Then f of 1 comma 6, 1 cube plus 6 square, that is also 37. So obviously 3 comma 10 is going to be 127. So the option 2 is the correct answer, 127. Okay. Next we are moving to logarithms. So logarithms, if for a positive real number a not equal to 1, a power m is equal to b. The index m is called the logarithm of b to the base a. So we write this as log base a, b is equal to m. See, there are two types of logarithms only, for common logarithm and natural logarithm. Okay, right. Natural logarithms, it will have a base as e. The common logarithm, you will have a base as 10. Okay, right. Product formula. There are few formulas which is used in logarithms. For a quantitative aptitude, they will ask these by using these basic formulas. They will ask some problems for. So product formula, log base a m n is equal to log m plus log n. Okay. Quotient formula, log of m by n is equal to log m minus log n. Power formula, n log m. Okay. Log of m power n is equal to n log m. Base changing formula. See, you should be very careful. Most of the problems they will ask from base changing and reciprocal relation part. So base changing formula, log of n power m is equal to log m divided by log n. So log of n power m is equal to log m divided by log n. Reciprocal, log of base b into a and log of a base into b is equal to 1. Or otherwise we can say that log of b base log of b base a is equal to 1 by log of a base b. Okay, so this one you can easily know that a power log of a power x is equal to x. Okay, right. Logarithm of 1 to any base is equal to 0. Log of a is equal to 1. See, forget about this base now. Okay, forget about this base. Nothing is given there means you have to take it as 10 as base. 10 as base. Log 1 is equal to 0. Log a base is equal to 1. Then there are two bases of logarithm exclusively used these days. One base is e and other base is 10. Okay. The logarithms to base e are called natural. The logarithm is to base 10 are called common logarithms. Okay. So log base 10 is equal to 1 since 10 power 1 is equal to 10. Okay. Right. For decimal, I have shown here log base 10 0.1 is equal to minus 2 since 10 power minus 2 is nothing but 0.01. Okay. Now evaluate. See the first problem, evaluate. Okay. Yeah, evaluate. Forget about the base. You just think log 200 plus log 40 plus 2 log 25. So what will be the answer? First, what formula we have to use here? Anybody can tell? Anybody can guess? So anybody can guess the answer, ma? Log of
Log AB, sir. log mn.
MNP. See, you have to extend it back. So what I have told, the product formula as log Mn is equal to log M plus log N. Okay, this is the formula I have shown there. Log MNP means log M plus log N plus log P. Okay, now, so according to that we will work now. So we can write it as, since we are having base as 10, MNP 200 plus 40. What about the third one? Anybody can tell the answer for third one? Before that we have to write one.
625, sir.
No, it's not 25. Here we are having 2 here. So
625, sir.
Pardon? 625, not. N log M, they have used here N log M formula. Therefore, you have to write it as log base 10.
4 log 10 base 4 log
No,
5 base
50
10.
50 ma, 50. I will show the answer. See here. First, see here. Log of, is it possible to erase this one? It is here. So, as log base 10, 200 plus 40 plus 25 square. Here, see this third one. One second. Third one, they have used N log M. So N log M means log base 10, 25 square. 25 square is nothing but, okay, 25 square is nothing but log of . So in PPT, every time we have to select that column. So I will write here log base 10, 200 plus 40 plus 15. Okay, so you should not have that. It is a multiplication. Okay, it is in the multiplication form. Then we have to find the answer. See here, 200. Okay, then 200, 40, 25, 25. So we can write it as. Now we will deal here. Yeah. See here, log M plus log N plus log P. It can be written as log M and P. 200 into 40 into 25 into 25 log base 10. 5 into 10 power 6. Here we have given. See, by multiplying all those things, we are getting some answer. We can call it as 5 into 10 power 6. So log base 10, 10 power 6, log base 10, 5. Okay. Here, log of 10 base 10 means we can write it as 1. So here again we are using the formula. Again we are using that formula N log M. Okay, N log M. Log M power N. Log M power N. I'm writing for this term. Okay, I'm writing for this term here. Log of 10 power 6. We forgot about this base. We can write it as 6 log 10. The base is 10. So log 10 base 10 means answer is 1. So 6 into 1. Here the answer is 1. So 6 log 10 base 10 is going to be 1 plus log plus 5. So 6 plus log of 5. 6 plus log of 5. Always you just forget about this base 10. If suppose nothing is given there means you take it as base as 10. Okay. So the option C is the correct here. Option C is the correct. Next, solve for x. Log 80x is equal to 6. Which one is the correct answer? Which one is the correct answer? You just guess it, ma. We will see whether it's right or wrong. That is not a problem. Because you are going to write the aptitude exam. No, during that time you have to think no. So just guess the answer. Any answers there? Take a 1 or 2 minutes. You just calculate it and tell me the answer. Then I will show the answer. What is the correct answer? Any guess? Right. See here.
No, B, sir.
Yeah, exactly.
B, sir.
Correct. Very
B,
good.
sir.
Very good. Good. Very good. 12,500 is the correct answer. See, by the definition of logarithm, 80x is equal to 10 power 6. Okay. So we can write the 10 power 6 as 10 into 10 power 5. Here in the left hand side, I have 80x is changed to 8x. How it was changed, ma? So both side we can write in 80, we can write it as 8 into 10. Okay, 8 into 10. Both the side I'm removing you that 10. So 8x is equal to 10 power 5. That is 1000 into 10 square. We can 10 power 5, we can write it as 1000 into 10 square. So 1000 into 10 square. Here, how we are getting this 125? This 8 is divided with this term. One second. So 8x is equal to 10 power 5. So this 10 power 5 is split into 1000 into 10 square. Here 8x we are having, x is equal to 1000 divided by 1000 into 10 square, we keep it as same, that is divided by 8. So these two we can check it out, 125. X into 125 into 100, we can write it as 12,500 exactly. So good. A few members were answered the correct answer. So 12,500 is the correct answer. Next we are moving to third problem. Evaluate log of 3 power 5, that is log base 3, 5, then log base 27, 25. So the answer they have given as 2 by 3, 3 power minus 1, C 3, D option is 3 by 2. So which one is the correct answer and what is the concept they have used here? Anybody can guess what is the concept they have used there? Anybody can guess and tell me? Base changing. You can call it as base changing.
Base changing, sir.
Log 3 divided by log 5, then log 25 divided by log 27. Here I am just writing this 25 as 5 square, this log 3 as, that is 27 as 3 power 3. We can write 3 power 3 as 27, 5 square is 25. Why we are doing all those things, sir? We have to find the answer because I am trying to cancel log 3 to log 3, then log 5 to log 5, remaining answer. See here, log 3 divided by log 5, 2 log 5 divided by 3 log 3. So we can strike out this log 5, log 5, log 3, log 3. So the option A is the correct answer, 2 by 3. Next part. Simplify log of 75 by 16, 2 into log of 5 by 9 plus log of 32 by 243. So listen carefully the middle term, minus 2 into log of 5 by 9. First we have the question in the form of n log m. First we have to deal that one, then we have to solve it. Okay. So anybody can guess which one is the correct answer here? Just to guess it.
2 log
2 log 3. Oh, good, very good answer. Then anybody any other answers, ma? Any other answers here? Right. So log 75. Pardon, pa? Which one? 1 minute. You asked 1 minute. Oh, I have shown the answer, so no problem. You just calculate it. Don't see the answer. Right. Log m n p, that is the concept here we have used. Okay. So the solution, log of 75 by 16 minus 2 into log of 5 by 9 plus log of 32 divided by 243, log of 75 by 16 minus log of 5 by 9 whole square plus log of 32 by 243. Okay.
Log 2, sir.
Which one, pa? Log 2 is the correct answer. See here, I'm having minus log of 25 by 81, but here it was changed to 2. I have just reversed it, ma. The negative sign to positive sign, I have just reversed it, 81 by 25. After simplifying these 3 terms, we are getting log 2 as answer. Okay. Next. Here also we are using base changing. Simplify 1 by log of xyz, see the base, first one xy, second one yz, third one zx. So which one is the correct option? Here A, B, C, D. Which one is the correct option?
A, sir.
A, correct. Your answer is correct. Now we will see that log of xyz base as x, y, z. We are by base changing formula. Here we are using as, okay, by base changing formula. Here we are using log of x, y, z as base. Okay, x, y, z as base in all the three terms. Okay. So after that we are applying log m n p. So base as x, y, z, x, y into y, z into z x. So log of x, y, z into x, y, z whole square. Again we are used that log m power n. M power n is nothing but n log m. So n log m. Here the base and the term are same. So log a base a means answer 1. So 2 into 1 is equal to 2. The answer is 2. Next one. So find the number of zeros after the decimal point in 3 by 4 whole power 500, given that log 3 is equal to 0.4771 and log 2 is equal to 0.3010. So which one is the correct answer? Anybody can tell me the answer? First of all, before we are going to deal the answer, how can we solve this problem? Any guess? So 3 by 4 whole power 500 they have given. So how can we solve this? Any idea? By using the logarithms, we are having product rule, quotient rule, base changing formula, then power formula, then reciprocal formula. So here, what are all the rule we can use here? 3 by 4 whole power 500. First we think about the n log m, that is log m power n. 3 by 4 as m, 500 as n. So we can write it as 500 log 3 by 4. Is it correct? See here, log of 3 by 4 whole power 500. So we can write it as n log m. Then after that, log m by n is equal to log m minus log n. Already we are having some values there. They have given us log 3 as 0.4771. So here also we are having log 3 as answer. But see the second one, log 4. So again we are rearranging as log 4 as 2 log 2. So 2 log 2. Now we are having the answer for log 2, 0.3010. After solving this, we are getting minus 62.4500. So the number of zeros after the decimal point is 62. Okay. After the decimal point, we are having only 6 and 2. So 62. Next. See the seventh one. 3 plus log base 4x is equal to 3 into log of y. Then express y in terms of x. I have given the answer also. See the first one. 3 into log of 4 base 4. We can write it as 3 into 1. We can write it as log of 4 base 4 plus log of x is equal to 3 into log of y. Okay. See the next step. These 3, how we are writing here? 1 second. I will solve it in the. Solve it in the. So only 5 more minutes, but I don't want to take much more time. So I will finish within the 5 minutes. I will finish. Okay. Only two more problems are there. We can finish. Okay. See here. 3. Then second one, log 4 base 4. We can call it as 1. So log m power n. So we can call it as 4 power 3. So 4 power 3 means 4 power 3. Solve it and show it, then only you can be able to understand. 3 plus log 4 power x is equal to what they have given for right hand side. 3 into log 4 base 4. Okay. So 3 into, we can write it as log 4 base 4, log of 4 power x is equal to 3 into log of 4 power y. So we can write it as n log m is equal to log m power n. So based on that, log of 4 into 4 power 3 is equal to log 4 log base 4 power base 4 x. Okay. Then we can write it as log base 4 as 4 power 3 into x is equal to 3 into log of base 4 into y. Okay. Now next step. So 64x Give it here. 4. See the right hand side. See the right hand side here. 3 into, okay, so here. Now 4 y cube. The right hand side is coming as y cube. Same procedure. You can write it as log base 4 y cube. Okay. So both the side we can cancel this logarithm means 64x is equal to y cube. So we are taking cube means 4 into cubic root of 3 is equal to y. Okay, cubic root of x. Cubic root of x is equal to y. So the answer is 4 cubic root of x. Okay, 4 into cubic root of x. Okay, option B is the correct answer. 4 into cubic root of x. The value of log 27 log base 4 64 is, see first log of 27 log base 64. 64 can be written as 4 power 3. So 64 can be written as 4 power 3. After that I have applied n log m. So next log 4 base 4 means we can call it as 1. So log base 27 into 3. So these 3 we can be written as 27 whole power 1 by 3. 27 whole power 1 by 3. Now again I am using n log m. 1 by 3 into log of 27 base 27 means it is 1. So the answer is 1 by 3. So D option is correct. Then last problem. So if 1 by 3 into log of a cube plus b cube into a plus b is equal to log of a plus b and a equal to 2b, then find the respective values of a and b. So 2 comma 1, 1 comma 2, 4 comma 3, 4 comma 2. Okay. See how we have solved here. So 1 by 3 into log of a cube plus b cube, the first step. Okay, 1 by 3 into log of a cube plus b cube into a plus b log of a plus b. I have taken the 3 to the right hand side, so I am writing as log of a cube plus b cube into a plus b is equal to 3 into log of a plus b. Next part. Next step, just cancelling the logarithm on both sides. A cube plus b cube into a plus b is equal to a plus b whole cube. Just I am bringing to denominator means the right hand side will change as a plus b whole square. But given a equal to 2b, so wherever I am having a, I am just replacing 2b. So 2b whole cube plus b cube is equal to 2b plus b. Therefore, left hand side is going to be 9b whole cube is equal to 9b square. So b is equal to 1. So b is equal to 1 means a equal to 2. Okay, a is equal to 2b. Therefore, a equal to 2. Therefore, the answer is 2 comma 1. 2 comma 1. So, is there anybody having any doubt? You please unmute your mic and ask me now. Is that 1 second? Only 1 second. Okay. Is there anybody having any doubt? You please unmute your mic and ask me now. I will explain the concepts more. Is there anybody having any doubt, Pa?
No, sir.
Okay, ma. Right. If suppose you're having any doubt means you feel free to text me or call me. Okay. So I'm Dr. Balaj. Okay, from mathematics department. Okay. Feel free to text me or call me. I will help you. So whenever you are having any, you do want to know any shortcuts or you are having any doubts means you can call me or text me. So that's all for today's session. We will conclude the today's session. Thank you all.
Sir,
Thank you, sir.
Yes, ma.
can
Yes.
I have this PPT, sir?
Yeah, I will send you, ma.
Okay, sir.
In which platform I have to send you, ma?
Anything is fine, sir.
Anything is
If
fine.
it
Yeah,
is,
please tell me, ma. Tell me, ma.
if it is in this chat box, also no problem, sir.
One second, you can tell me how to share in the chat box, ma. Or shall I share it to your number, WhatsApp number, ma?
Okay, sir.
You kindly take down my number.
Okay, sir. I'll take down your number, sir.
Yeah, you take down my number 91766.
Yes, sir.
91766. 16776.
Okay, sir.
Okay, ma, I will share it to you, ma. Okay.